We're on topic 21, page 117, and we're going to start off with definition of a quadratic equation. That's the first part. And we're going to do the graph of a quadratic equation or a parabola. We're going to show the different parts. And finally, we're going to do an illustrative example of how to draw the graph of a quadratic equation. So first of all, let's look at the definition. It's an equation in two variables, x and y. So here we have y equals ax squared plus bx plus c. So that's a quadratic equation, two variables, x and y. Y equals, and here we have the x term, ax squared plus bx plus c. Now there's certain provisos that a, b, and c must be belong to the real number set, or it must be a real numbers. That's topic 1. And a cannot equal 0. The graph of this equation, graph associated with this equation, is called a parabola. So, as we said, the coefficient of the x squared term, this a value cannot equal 0 in order for it to be a quadratic equation. Some examples are y equals x squared. You don't necessarily have to have a bx and a c term. So it could just be y equals x squared, or y equals 3x squared, or y equals minus 2x squared. Another example is y equals x squared plus x. That's another example of a quadratic equation. And here we see a third example, y equals minus 3x squared plus 5x minus 7. So now let's go to look at the graph associated with the quadratic equation. And we are going to look at this graph and consistently go through 4 parts here. We're going to look at the axis of symmetry, which is right here. So the first part, let me just go down here, scroll down here. We're going to look for the axis of symmetry. We're going to look for the X-intercepts of the graph. We're going to look for the Y-intercept, and we're going to look at the vertex. So let's take a look at that. First of all, we're going to look at the axis of symmetry, and we're going to go over the equation, how we get this. This is the axis of symmetry here, this dotted line going down here. And essentially, it divides the graph into 2 equal parts, symmetrical parts, where one is just the mirror image of the other. So if you imagine this to be sort of like a face here, then the axis of symmetry, let's say we have a perfectly symmetrical face, would lie right down the middle of the nose. We would have ears here and ears here. And so the axis of symmetry is one of the identifying parts of a parabola. And it's given by the equation x equals minus b over 2a. So if we have the graph y equals ax squared plus bx plus c, then the axis of symmetry is given as minus b over 2a. So second part that we have to know is the x-intercepts. And the x-intercepts simply means right here where the graph crosses the x-axis. The x-intercepts are where the graph crosses the x-intercepts, and this is where y equals 0. So if y equals ax squared plus bx plus c, along this graph you can see if you go down, 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 right here y is 0. So along where the graph crosses the x-axis, y equals 0. So these are called the x-intercepts. There could be one intercept. There could be no intercepts. there could be two intercepts. So we're going to see the different kinds of cases. Okay, the third point of interest is the point at which the graph crosses the y-axis. And where it crosses the y-axis right here, x is equal to 0. Well, if x is equal to 0 here, you can see if x is equal to 0, this term is 0 and that term is 0, and y becomes equal to c. We're going to go over this, each one first again. And the fourth part that we're going to be concerned with is the vertex. And the vertex is the case that represents, in this case, only a minimum point on a parabola, on the example that we're talking about here. So the first thing, to get the vertex, we need the x value, we need an x value, and we need a y value. The x value is the axis of symmetry value. And then we just substitute this into the equation to find the corresponding y value. So, over this again, we can see here that the characteristics we're concerned with are the axis of symmetry, right here, the x-intercepts, Y-intercept, and this point right down here in this particular graph, for this graph, is a minimum. As you see, the graph keeps going down, 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 and then it starts to go up, 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 up. So this represents a minimum point on the graph, and that is the vertex. The x value of the vertex is obtained by the equation minus b over 2a, and then you just put that value into this equation. You know the x value, and you calculate what y is. Now we're going to see lots of examples of this, so let's just go over this again. The axis of symmetry minus b over 2a. The axis of symmetry is a line that essentially cuts the graph into two equal parts. The x-intercepts, where the parabola crosses the x-axis, found by setting y equal to 0. So you set y equal to 0, and then, if necessary, you factor this, or you can use the quadratic equation to solve it. So we're going to see lots of these examples, so don't worry. We're going to go over this on at least 5, 6, 7, 8 examples, so you're going to see. The y-intercept is where the parabola crosses the y-axis, and here x is 0. So that y equals c, because if you substitute in here, and this is 0, and this is 0, because x is 0, then y will equal c. The vertex represents a minimum point on the parabola, only for this case, because you're going to see other cases. The x value of the vertex is minus 2a. To obtain the corresponding value, substitute the x value, what you get here, minus b over 2a, into this, and you get the corresponding y value. So you can see over here, there's an x value and a y value associated with a vertex. Now, if the graph is shaped like this, in our case, the graph is shaped like this, I'm going to call this a happier smiley face, then the coefficient has to be greater than 0, has to be positive. The coefficient of x squared. Remember the equation here. This has to be greater than 0. We can also have a graph shaped like a frown. When it's shaped like a frown, this point is now a maximum. Here, we go down, and this is a minimum point. But if a is less than 0, then the graph is shaped like an unhappy face or a frown, and this is a maximum. So we're going to see two kinds of cases, a happier smiley face or a frown kind of a face. The vertex for a smiley face, this one here, is a minimum. If the graph is shaped like this, it's a maximum, and that's a frown. Okay? So we're going to see these two kinds of cases. Now, one thing we can always do is plot a graph by substituting x values into the equation y equals ax squared plus bx plus c. Just substitute a value in, say x is equal to 1, work out what it is, and then we know the y value. And once we know the x and y values, we can plot a graph. So let's see now how we use this in a specific example. Here we have y equals x squared minus 6x plus 5. And you see here we have the y-intercept, the x-intercepts, and the vertex. Now we're going to go to each one of these and, of course, the axis of symmetry. So here's the equation, y equals x squared minus 6x plus 5. These calculations are identical to what is shown above, but I'm just going to go into more detail. Here's the equation that we're dealing with. In this case, a is 1 because the coefficient of x squared is 1. B equals minus 6 because the coefficient of this term here, this is b right here, and c is equal to 5. The axis of symmetry is minus b over 2a, which is minus, and b is minus 6, so minus 6 is plus 6 divided by 2 is 3. So the equation x equals 3, as you can see, divides the graph into 2. So here's x equals 3. There's the equation. This is the axis of symmetry. This half here is the same as this half here. So it's symmetry, meaning that one half, the left side, is the mirror image of the right side. So we first of all get the axis of symmetry. That's number 1. Number 2, in order to find the x-intercepts, y is 0. Because where the graph crosses the x-axis, y is equal to 0. So we set y equal to 0. Here, x squared minus 6x plus 5 equals 0. We factor this as x minus 5, x minus 1 equals 0. Set x minus 5 equal to 0, and then x equals 5, and set x minus 1 equal to 0, and x equals 1. So we know there are two intercepts, x-intercepts 5 and 1. Because y is 0, the 2 points are 5, 0, and 1, 0. And you can see them right here, 1, 0, and 5, 0. So these are my two x-intercepts right here. Not every graph will have two intercepts. Some graphs will have one intercept, and some graphs will have no intercept. So we're going to see different cases as we go along. So what do we have now? We have the axis of symmetry, and we have the two x-intercepts. And the y-intercept is found by setting x equal to 0. So into this equation here, y equals c. So the value of c is 5. So the y-intercept is 5, and this is represented by the point 0, 5. And if we go up here, you can see here's the y-intercept. So we have the two x-intercepts, we have the axis of symmetry, and we have the y-intercept. The final thing that we want to calculate is the vertex, or the minimum point. Now the x value for this is always obtained from the value of the axis of symmetry. So x equals 3. We substitute this into y equals x squared minus 6x plus 5 right here. So 3 squared for the x minus 6 times 3 plus 5. 3 squared is 9. 6 times 3 is minus 18. And we have plus 5. 9 minus 18 is what? Minus 9. minus 9 plus 5 is minus 4. So the vertex is 3 minus 4, or the minimum point. And if we go over here, you can see the minimum point. So let's go over this again. What was the first thing we did? We calculated the axis of symmetry, and that was x equal to 3. X equal to 3 is this line right here. So there's our axis of symmetry. We then calculated the x-intercepts by setting y equal to 0. So to find the x-intercepts, here you can see it. All this here is just a repeat, but I've just given a little more detail in my notes. So we have the x-intercepts, and this is the y-intercept here. We set x equal to 0 because along this line, x is equal to 0. Okay, if we go along this line, x is 0. This line here, x is 0. So when x is 0, we plug it into the equation right here. When x is 0, y comes out to be 5. And then we get the vertex from calculating the axis of symmetry, plugging this x value back into this equation, and we find that the corresponding value of y was minus 4. Now, there is one little interesting thing here. You can see here what happens. Here we have the y-intercept. Here we have the x-intercept. Here we have the vertex. If we connect this to this, to this, to this, we have the basis of the graph. So that's what we've got here, this, and this. Now, one interesting thing, note that the x value of the vertex, or the axis of symmetry, this value right here, lies halfway between 1 and 5. If you add 1 and 5, you get 6. 6 divided by 2 gives you 3. So that's always a check that your x value on your vertex should be halfway in between these two values here if there are two intercepts. Now, we can also draw a graph by choosing x values and calculating the corresponding value of y. So this is a totally different way of choosing it. Let's say we chose values of x, integer values of x from 0 to 6. So 0, 1, 2, 3, 4, 5, 6. And we substitute here. If x is 0, then y is 5. So one point is 0, 5. Because the ordered pair is an x and a y value, 0, 5. When x is 1, 1 squared is 1, minus 6 times 1 is minus 6, plus 5. When we add this up, we get 0. So 1, 0. When x is 1, y is 0. If x is 2, we substitute that in here. 2 squared is 4, minus 6 times 2 is 12, plus 5, that gives us minus 3. So 2 minus 3 is another ordered pair that fits on the graph. These are all ordered pairs that fits on the graph. We chose x equal to 3, then 3 squared is 9, minus 6 times 3 is minus 18, plus 5 equals minus 4. So when x is 3, y is minus 4. That happens to be the vertex. Now, when we choose 4, when x is 4, we get 4 squared, 16, minus 6 times 4 is 24, plus 5. 16 minus 24 plus 5 is minus 3. So 4 minus 3 is another point. We choose x is 5. 5 squared minus 30. 25 is 5 squared minus 30 plus 5 equals 0. So when x is 5, y is 0. That's another ordered pair. And finally, when x is 6, we get 6 squared, 36, minus 6 times 6 is 36. So 36 minus 36 plus 5 is equal to, and there's an error here, this should be the number 5 right here. So this is an error here, and I'm just going to go back and change that to the number 5 here, put the number 5, okay, go here. Okay, so we have all these points. Now notice that around the vertex, the symmetry that happens, this is the vertex right here. So 2 minus 3 and 4 minus 3, the y values are the same. They're both minus 3. Here, when x is 1 and x is 5, the y values are both 0. I've shown that in blue. And then here you have 5 and 5. So again, if you connect all these points, you can see the points that I've shown. Here we have 5, 0, right here. Here's 6, 5. Right here is 6, 5. And here is 5, 0. And then we go to 4 minus 3 and 3 minus 4. So 6, 5, 5, 0, 4 minus 3, 3 minus 4. Here 6, 5, 5, 0, 4 minus 3, and 3 minus 4. There's the thing. Notice the symmetry here. The y values are the same here. The y values are the same here. The y values are the same here. Okay, and there's the axis of symmetry right there. That's just a different way of doing it. What we said is, instead of using the method that we used, which is find the x and y intercepts, you could just choose numbers. But you have to choose the right numbers. That's one of the problems here. You have to know what numbers to choose in order to get a real shape of the graph. But it does represent an alternate way of doing this, looking